Hello all, welcome back to operating system course. So in the last class we had studied about FCFS algorithm, right? So we will today move on to the next algorithm, which is shortest job first. So short form is SJF algorithm, okay? So last class we had seen FCFS algorithm, right? And that was non-preemptive, right? FCFS was non-preemptive. That means whenever a process has been given the CPU, it would be executed fully. That means the entire process would be terminated or executed fully. Then only the CPU would be given to the next process in the ready queue. But here in the SJF, what will happen is there are two flavors of SJF. SJF can be preemptive. It can also be non-preemptive. Okay. So in the SJF algorithm, you can preempt the process whenever you have given it to the CPU for execution. That means preemption means what? So whenever a process has been given to CPU for execution, say suppose another process, or it can be that when whatever is executing, it can be stopped in between, and then the CPU can be given to the next process in the ready queue. Okay, so this is preemption. Non-preemption in the sense like your FCFS, the CPU is whenever it is allocated to one process, that process would be entirely executed. Then only it would be CPU would be given to the next process in the queue. So we will learn only about SJF non-preemption. Okay, non-preemption in the sense the CPU would not be forcefully taken from the process. We would see the non-preemption version of the SJF. Now this preemption version of the SJF is also called as shortest remaining time first algorithm. Okay, so whenever question is asked, the problem is given and they are telling you to draw the Gantt chart, calculate waiting time, turnaround time using SJF. Whenever they specifically give you using SJF, that means you have to use SJF non-preemption flavor of the SJF. Okay, I'll tell you how to solve the problem using non-preemptive method. Okay, so another version is possible, that is in the SJF it can be preempted. Process can be preempted, right? So the process can be preempted, and that we call it as shortest remaining time first, SRTF. Okay, so shortest remaining time first, that means SJF with preemption. Only SJF means it is non-preemption. Okay, fine. So how this SJF works? So in the FCFS, what we had seen in the first come first serve, whenever the process, you will be given the process order, right? Like process will arrive in the order P1, P2, P3, P4, something like this at time 0. So what would you have done in that case in FCFS? So you would first take P1, then move to P2, then P3 likewise, right? But what will happen in SJF is we will consider the burst time of the processes. Okay, we will only focus on the burst time of the processes in the SJF. Fine. And how do we focus on the burst time? So wherever the process it has the lesser CPU burst time, that process would be taken for execution first. For example, I'll give you example like we have say three process P1, P2, P3. Okay, consider we have three process and the burst time is say 21, 3 and 5. Okay, if we were using FCFS, then we would have taken P1 first, P2 next, then last P3. And in the SJF, what will happen is like you focus on the burst time, not the order in which the process have arrived. Focus on the burst time. Now in the burst time, whichever has the shortest burst time, right? So you consider that process first for execution. Okay, in our case, the we have 21, 3 and 5 as the burst time. The lowest or the smallest here is this one, right? So 3 is the smallest one. So first what we do, we will consider P2 for execution. First we will consider P2 for execution. Once this execution is over, then again we'll check, right? Again we have two process P1 and P3. We'll check the burst time of the process. It is 21 and 5. Which is smallest among that? So 5 is the smallest. Then at the second time what you do? You choose P3 and lastly you choose P1. Okay. So in the SJF what you have to keep in mind is like focus on the burst time, and whichever process has the lowest or the smallest burst time you pick that for execution first. Next time again the compare the burst time of the process remaining, again choose the smallest one and do the execution. But say suppose you have processes which has same burst time, then what you do? Like this one, 21, 3 and 3. So for P1 it is 21, P2 and P3 it is 3 and 3 milliseconds. So now which one you consider for execution, right? So in this situation, wherever you have processes, more than one process having the same burst time, in this case you have to choose FCFS algorithm. That means first consider P1, P2, P3, check for the burst time. You can see two processes are having the same burst time. In this case, what you do? Apply FCFS for P2 and P3. So if you apply FCFS for P2 and P3, what will happen? P2 will come into picture first, execute that one, then take P3 and lastly take P1. Okay, so we will take one example and then you'll come to know that. Okay. So this is the example. So consider we have four processes P1, P2, P3, P4 having the burst time 6, 8, 7 and 3. So we will consider or we will assume that all of these processes have arrived in the order P1, P2, P3, P4 and at the time 0. Okay, the arrival time for all the process is 0. That is what we are assuming here. Fine. So first thing you have to draw the Gantt chart, right? So here first you have to check which process has got the smallest burst time. So in our case this process P4 it has the smallest burst time, right? Compare 6, 8, 7, 3, the smallest one is 3. That's why we first execute process P4. Okay, in the Gantt chart first represent P4. Okay, the arrival time is 0, then the burst time is 3, that means it requires 3 milliseconds to execute. Write 3 over here. Okay, P4 is done. Next check which process has got the smallest burst time. Compare 6, 8, 7. So which is smallest among this? So 6 is smallest, right? In the Gantt chart represent P1 next. So P1 how you have to represent? So you have to represent like this, P1 here, then how much time it needs for completion? 6, right? So 6 plus 3, 9 over here. Okay, so two processes are done. Now compare P2 and P3 burst time 8 and 7. So 7 is smallest, right? So represent P3 in the Gantt chart and then what do you do? Add 7 this burst time to this waiting time, right? 9 plus 7 is 16 here. Then the remaining one is P2, represent P2 here, 16 plus 8 it is 24. Then cross verify whether this answer is same. Add up all these things, you will get 24 and this is one cross verification. Okay. Next we have to calculate the waiting time. So waiting time of process P1, P2, P3 and P4. Okay, fine. First we'll see the Gantt chart and we'll calculate the waiting time. So check for process P1 how much millisecond it has waited to get the CPU. It has waited for 3 milliseconds, right? So P1 waiting time is 3 milliseconds. So P2 it has waited 16 milliseconds over here. So write 16 here. P3 it has waited 9 milliseconds, mention here, and P4 it is 0 milliseconds, mention here. Fine. Now calculate the average waiting time, that is sum of all these things divided by total number of processes. So 3 plus 16 plus 9 plus 0 whole divided by 4, that comes up to 7 milliseconds. So once this is done, what you have to do next is you have to calculate turnaround time, right? So turnaround time I'll write over here for process P1, P2, P3 and P4. Okay. By looking into the Gantt chart, you have to write the turnaround time. So what is the turnaround time for process P1? When did it complete? Here, right? So it is 9 milliseconds. Then P2, it completed here. So it is 24 milliseconds. Then P3, it is here 16 milliseconds, and P4 it is 3 milliseconds. Okay. Now calculate average turnaround time. So average turnaround time is nothing but addition of all these things divided by 4. That is the total number of process, which comes up to like 9 plus 24 plus 16 plus 3. It is 52 by 4. That comes around 13 milliseconds. Fine. So this is how you calculate your turnaround time as well as waiting time. So how you have calculated this one? So just by looking into the Gantt chart, you have calculated this one, right? So apply the formula and check whether you are getting the correct answer. So whenever using formula, you have to first calculate the turnaround time and then calculate the waiting time, right? So, okay, let us apply or first calculate the turnaround time using the formula. The formula for turnaround time is completion time minus the arrival time, right? So for process P1, what is the completion time? It is 9 milliseconds. What is the arrival time? We have assumed that all processes have arrived at 0 millisecond, right? So 9 minus 0 is 9 millisecond. P2 completion time is 24 minus arrival is 0, that means 24 millisecond. P3 16 over here, 16 minus 0 is again 16. P4 3, 3 minus arrival time is 0, 3 minus 0 is again 3 millisecond. That is easy, right? So 13 milliseconds is the average turnaround time. So now let us calculate the waiting time using the formula. So formula for waiting time is turnaround time minus the burst time. Okay. So what is the turnaround time of P1? It is 9 milliseconds. Okay. So 9 minus 6, that is 3 milliseconds. Correct? Then check for P2. The turnaround time is 24 minus the burst time, it is 8. 24 minus 8, again 16 milliseconds is the waiting time for P2. P3 turnaround time is 16 minus 7, that is 9 milliseconds waiting time, right? So for P4, 3 minus 3, it comes up to 0. Fine. This is how you calculate using the formula. So now let us compare FCFS and SJF algorithm. So first thing, the basic comparison here is your FCFS, it executes the process in the order which they arrive. That is, the process which arrives first will be executed first. But in the SJF, what will happen? The process which has the smallest burst time would be executed first. Okay. And in the FCFS, we had that FCFS is non-preemptive in nature, right? But SJF, it can be preemptive as well as non-preemptive. And the preemptive SJF, we call it as shortest remaining time first, SRTF. Okay. Then you compare the waiting time of both the algorithms. Okay. So in the FCFS, the result is quite long waiting time for the process, and that's why what the average waiting time, whatever you are getting, it is quite longer. But in the SJF, what will happen? The waiting time for given set of process, it would be minimum. Okay. So compared to your FCFS and SJF, your SJF, we call it as optimal, or it has the minimal waiting time. Okay. I'll solve another problem in the next video.